Welcome, dear students, to your algebra series, and this is your lesson 2. And here I'm going to do examination type questions with you, some typical examination type questions on algebraic expressions as well as algebraic equations. We will do a bit of simplification and also taking like terms together in this lesson. So I hope you enjoy it. Let's jump right into it. So here we already have one typical examination type question, and it was a question 5 of a certain year. So here is what we have to do here. We have to consider the expression 7x squared plus 5x plus 4. Well, if you remember, that would mean that we have 3 terms. Remember, terms are separated by plus or minus. So here we have the first term here just before the plus, and then after the plus, that's the second, and that one is the third term. Okay, so we have 3 terms here. So let's figure out what we have to do. So the first question was, write down the constant term. Remember, a constant term is the one that doesn't have a variable on it. So as you can see, all these terms have got a variable on them except this 4 down here. So the constant term this time will just be 4. So it was quite easy, so therefore that's why it's 1 mark. So we still have to carry on and answer the rest of the question. So what is the degree of the expression? Right? When we talk about the degree, like I've already indicated, is the highest power in the algebraic expression that you have. So in this situation, the highest power of the variable is 2. So in this situation, it is the second degree. Now, what was going to change? Let me quickly give you, say, this expression, 3x cubed plus 4x squared minus 3x plus 1. Well, as you can see here, the highest power is 3. So here it was going to be a third degree because the highest power, which is this power here, that's where, okay, the variable's highest power is 3. So it was going to be a third degree polynomial in that situation. And how many terms? That'll be 1, 2, 3, 4 terms. And the constant will be 1. Okay, so that's what you have to remember in these algebraic expressions. All right, so what else was on this question? So there was this next question, write down the coefficient of the second term. So for us to see the second term, we have to go back, and this, like we said, is the first term, that's the second, and that's the third. So the second term there is clearly seen to be positive 5x. So you write it as 5x. I think it would be wise if I copy that equation since I'm going to need it. So let me put it in red here quickly. 7x squared plus 5x plus 4. That is the expression we have. Now let's answer the remaining part of these questions. So what do we have down here? Let's see quickly. Okay. Right, write down the coefficient of the second term. We have already written that part. I may have erased it. Right, let's go write it right back. Okay, the second term is just 5. Right, now calculate the value of the expression if x is equal to -1. So you're going to substitute wherever there is x, you put -1. So I'm going to do so. I'm going to put -1 like this. Plus 5, and then that's -1 again, plus 4. That's all you have to do. So just remember, -1 squared is the same as saying -1 times -1. So you're going to have to say that's 1. So this will be 7 still. 5 times -1 will give you -5 on that one. So quickly put -5 there. And then plus 4. That's all you have to do. So 7 minus 5, that would be 2. 2 plus 4, if I must show it, 2 plus 4 will give us 6. So our final answer will simply be 6. So this was an examination type question. I believe you find this type of thing easy. But let's have more practice with more questions. So here let's have a second one, an examination type question. So again, we have 1, the first term, second, and 3. third term here. So again, we have 3 terms as it appears. So what is the coefficient of x squared? As you can see, it's negative 8x squared that you see. So the coefficient is the number just before the x squared. And in this situation, it would be negative 8. Write down the constant term. Which term there of the 3 terms we labeled does not have x? Well, that would be negative 7. Okay. Now you want to write the expression in descending powers of x. So descending meaning you have to start with a big one, the bigger number, and going to the smaller numbers. So here you're going to start with the power of 2 since this is the maximum. So you write together with the coefficient. So that's minus 8x squared. Then that 2x means it's actually positive 2x. And then you write the constant, which we agreed was negative 7. So you managed to write the expression in descending powers of x. And then calculate the value of the expression if x is equal to a half. It's a matter of you substituting. So you can either substitute it into this one or into the original one. Or since they gave you this one, just substitute into the one given to you. So it's 2 there, and then I'm going to put a half. In place of x, that's what it means. And then you have negative 8. You put a half over there. Don't forget to square it. And whenever it's squared, careful, there might be some things that happen. So in this situation, notice how this 2 and that 2 will cancel. They will cancel because it's the same number. Then we have negative 7. At this point, also notice a half squared, you say 1 squared. It's 1 times 1, that's 1. And then you also say 2 squared, which is 2 times 2, which is like 4. So at this point, this is when you have to appreciate how the 4 will cancel an 8, and then that is a 2. So what is an expression left? What are the numbers left? So minus 2 times 1 will become negative 2. So here we are left with just 1 minus 7, which will be negative 6. So negative 6 minus 2 will be negative 8 as your final answer. So that is precisely what I was hoping you would do for this one. I hope you got it right when you tried it. Well, I believe you are ready for a little exercise on this. So let me just see if I can give you one. So do this exercise on your own and let's see if you understood the examples that I gave to you. Right, here we have to consider, thank you if you tried it. So here you have to consider the expression given below and answer the following questions. Again, it does look like the ones I have here have 3 terms. So the third term is plus 5, the first term is minus 2x squared, the second term is minus 3x. How many terms are there in the expression? Let's write 3 terms quickly. So I'm sure you got your 1 mark there. What is the constant term in the expression? Well, that is that positive 5, the one that doesn't have x on it. You can write it as plus 5 or you can just write it as a 5. Okay, now after this you have to find the coefficient of the second term. So since we have already numbered our terms, the second term here is a negative 3x. So you want the coefficient. So the coefficient of x at this point will be negative 3. Okay, so that would be the solution for that. Write down the degree of the expression. So this polynomial, according to what we are seeing, the maximum power that is here is 2. So again, it is a second degree polynomial, or second degree expression as they would like to do it now. Calculate the value of the expression if x is equal to negative 2. That must have been easy for you again. So how do we handle it? In place of x, wherever I see x, I'm going to put negative 2. So notice how I am making the substitutions in there. So I'm going to put plus 5. So here you just have to be careful with your numbers. That is all there is to it. So I'm going to do it slowly and say here we have negative 2. Please notice when we say negative 2 squared, it's like negative 2 times negative 2. Well, that would be positive 4. Let me keep it as positive 4. So what is minus 3 times 2? Firstly, let's ask what is minus times minus? Well, that would be a plus. and 3 times 2 will give us 6. Okay? 3 times 2 will give us 6. And then we're going to just write plus 5 over there. Well, to finish it off, minus 2 times 4 will give us negative 8, as we know. And then that's plus 6 plus 5, like that. Okay, so let's finish it off now. I think all you need to do is to add the numbers. So it's like 6 plus 5, that would be 11. 11 minus 8 should be something equal to 3, isn't it? Okay, so I hope you got that one right, everything there. Let's see what else you are expected to do in this lesson. Well, I also wanted you to remember your like and unlike terms. So we have a few of them here to do. So I hope you'll be, let's have a few examples first. So here I have this first one. We have to simplify the following. I want you to just, for now, I want to just rearrange, putting things that are similar next to each other. So 2xy there, and minus 25xy. Do you see these have got the same things? They all have xy. So I'm collecting things with xy, meaning they are like terms. Okay, I'm done with that. So what else do we have? We also have terms like negative 17x. So I want to write that one over here. And then do we have anything with x? Again, it doesn't look like it. Then what is remaining are these terms here. I'm going to highlight them in red. So we have this one, which is positive 8y, and that one is positive 9y. So let me just write that one down, positive 8y, and then we have positive 9y like this. So those are the terms. If I may ask you, when we started off, how many terms did we have? Well, we had 1, 2, 3, 4, 5, 6 terms, isn't it? So for now, I haven't grouped them yet. I haven't added the like terms yet, so these ones should still be 6. That's 1, 2, 3, 4, 5, 6 terms. So now take the like terms together and let's see what you get over there, right? So the first thing you do is to say 2 minus 25. It's plus 2 minus 25. You take the sign of the bigger number, which is negative, and then you subtract 25 minus 3. That will be negative 23xy. Again, negative 23xy plus 1. That will be negative 22y. Okay, and negative 22xy rather. So I am going to say, just for consistency, I'm going to write it in green again, negative 22xy. Then we have that negative 17x. And then the ones in red, what will they become? Let's add them together. What is 8 plus 9? That should be known to be 17y. So at this point, I collected like terms together, and there is nothing else I can do. We cannot add x, y, and x and y together. So we just leave the expression where it is right now. Okay, so that's how you handle that. Let's quickly see. If you do not quite understand, check the previous lesson where everything was explained thoroughly. Okay, simplify the following expression. Again, we're going to have to collect like terms. At this point, I expect you to see them faster than before. So let's quickly see if you noticed which ones were your like terms. So here, I'm noticing we have 2x and negative 3x. Okay, those are like terms. Again, negative 3y is on its own. Let me put it in a different color. We have negative 3y and minus y, these ones. Okay, they are like terms. And then again, we have numbers. So the numbers, let's put them again separately. I see plus 4 here, and then there is this negative 2. So I wrote them in such a way that I can quickly simplify them. You don't have to write this step whenever you are very confident with yourself. But before you become confident, this will be the first way. This will be a safe way of doing it. So 2 minus 3. You take the sign of the bigger number, which is negative, and then you subtract the 2. 3 and 2, the difference between them is 1. So it will be negative x. And then these have got the same sign. You take the sign and then you add the numbers. Remember that's how we do addition of like, so 3 plus 1 will become 4, so it will be minus 4y. Because these ones have got the same sign, you take the sign and you add the numbers. Okay, so 4 minus 2, well, that one is well known to be 2. So this right here should be the final answer you got when you simplify that expression. Okay. We also have another one here. So for this one, I want to do something that I wasn't doing on the other ones. So they want you to add. So I'm going to say to write the 2b and negative 3a like this and minus c. They want you to add, but this one, whenever you say add that one and that, I want you to put the second expression inside the brackets. The reason I'm doing this is for when they say subtract, the signs will change then. At this point, when I say plus, this plus that you're seeing here, it doesn't change the signs that are inside the bracket. So at this point, it looks like it's not important to put that plus because the expression will come back exactly as it is. However, if this was a negative sign, every sign inside these brackets here was going to change. Okay, so I'm just going to, since nothing will change, I'm going to collect them together now. The minus 4b, I think you're noticing that this one here and that one are like terms. And then minus 3a, negative 3a, let's write negative 3a here, and also this term here, and there is an a, it will be plus a. So I'm going to write it as plus a. Okay, then there is c. C, when we handle c, we'll have to notice there is this negative c, which is over here, and then we have plus 2c on the other side. And then we finish it off. Okay, to finish it off, let me just put all of them in the same color. 2b minus 4b, that would be negative 2. Different signs, you take the sign of the bigger number and you subtract the 2. So it will be negative 2b. Again, it's negative 3 plus 1. Again, we have different signs. So we take the sign of the bigger number, then we say 3 minus 1, that would be 2. Minus c plus 2c. Again, we have different signs. You take the sign of the bigger number and you subtract 2 minus 1. That will give you just c. So this right here should be an expression that you get when you simplify that. Okay, so I think now that I have shown you how to simplify, it's important that we do a small exercise together. Let's see if you're getting this. And if I also throw in brackets there, will you be able to survive it, you know? So let's see the first one. Since it already has brackets, I think most of you would like to just first of all see me doing it and then try yours later. So here I am going to just multiply 3 in. You distribute 3. 3 has to multiply in there. It has to multiply the second term, and it has to multiply even the third term. So we say you distribute the number just before the brackets. So it will be 3x squared, and then it will be plus 6x, and then 3 times 3 will become 9, you know. So we are done distributing the first one. So what about on the second bracket? Well, this negative 3 should multiply x squared, so it will be negative 3x squared. Again, it should multiply the second term, so negative 3 times plus 4, so negative 3 times 4, I believe you notice it's negative 12, and then we put an x there, okay, because 3 times 4 is 12, and then x is on its own over there. So this right here, is precisely how you're going to handle things. So because of, I think now you have an idea. So the like terms will be this one and that one for now. I think you can see that. So what is 3x squared minus 3x squared? Well, those ones are cancelling out, so I don't have to write 0x squared. I don't have to do it. Okay, so that's another one. Now we also have things that have x on them, and which ones are they? We have this plus 6x, which is over here, and then we have this minus 12x, which is over there. So plus 6 minus 12, we have two different signs. You take the sign of the bigger number, which is negative, and then you say 12 minus 6, which is going to be 6. So the answer will be 6x there. I'm done with the things with x, and as you are noticing, that 9 is the remaining thing there. So I just have to take this 9 as it is. So I'll just say plus 9. So this is how we simplify things with brackets. This will be the final answer after you simplify. You will quickly get minus 6x plus 9. Okay, so what else is remaining? You now have to do these ones where you simplify. So while we are still at it, I just feel let's throw in a little fraction and see if you got it. But before I do a fraction, let me do the second one first, because it is kind of similar to the one we just finished doing. Okay, 2x must multiply that, and again 2x must multiply that. So what is 2x times 3x? What you have to do is to say 2 times 3, you will get 6. And then x times x, it's like x to the power 1 times x to the power 1. You add the exponents, it will become x squared. Okay, now what is 2x times 1? Well, that one will simply be 2x. I think you're grasping it. Okay, now for the second one, the negative x again has to multiply into the bracket. You distribute, we say you distribute it into the bracket. So negative, because of that negative, everything inside these brackets will change the sign. So we're going to say negative x times x. We know x times x will be x squared, but we don't forget to say minus x squared because of that negative. And then negative x times 3 will be minus 3x. So that is what we have now. We managed to get rid of the brackets. After getting rid of the brackets, the next thing we do is to take like terms, such as that one, and again this one right here. So those are things with x squared. So 6 minus 1, I believe you're noticing that the bigger number is positive this time. So it's easy. You just subtract 6 and 1. You take the sign of 6, and then you just write it as it is. We know that that one is easy for you. Okay, then what about negative 3x and positive 2x? Well, here you get negative. You take the sign of the bigger number and you subtract the 2. So this right here will be the solution for this. Okay, so now we also have a fraction that we have here. We have a fraction that is here. So let's just see how we handle fractions as well while we are still here. So this expression that we have on 3.21, I always say if you have an expression like this, if the denominator is one term, on the denominator you can see it's just 2x. So I suggest that you go and you actually split the fraction and do this. This is what I mean. And then you go and you put 2x squared like this. You are allowed to do this as long as the denominator has got one term. Okay, on the numerator you can see that there are 3 terms, but on the denominator it's just one term. So we call this process splitting the fraction. So once you split the fraction like that, now the next thing you do is to just simplify. It's a very simple task, because you are going to actually say 2 into 6 and you get 3. Remember, when you did exponents, this is more like x to the power 1, x to the power 1 everywhere. So when you divide the same base, x cubed and x to the power 1, you just have to subtract 3 minus 1. Here you get x squared. The same applies here. The 2's are cancelling, so you get 1, but 2 minus 1 will be x to the power of 1 left. Okay, so 2 goes how many times into 4? It will go 2 times. So it will be plus 2. Here, I think everyone can see that the x and the x will cancel. So once you do that, you'll be left with an expression such as this one, where you're noticing that there are no like terms whatsoever on it. So you leave it like that. So you have finished simplifying it. Okay, so let's go to that other one. Now that you know how to handle brackets, I'm going to challenge you to these 3 that are here. So pause and make sure you answer this first, and then afterwards you are welcome to come and check how I'm going to solve this. Okay, good. So here, notice what I'm saying. It's as if this expression here is subtracting the second expression. Like I've indicated in that example, the bracket is important. Everything inside the bracket will change its sign because of that negative that is over there. So I'm going to rewrite that as it is, like 15a plus 24b, like this, and then I'm going to say minus 13c. But when I go to the second bracket, notice this will be minus 12a. In fact, for you to see it properly, let me just change the color to green. So it will be minus 12a for the second one, like this. The negative is actually being distributed 3 times in there because it's like a number, it's like -1. So you have to distribute it. So it will be minus 12a, and then it will change that one to plus 18b, and then it will change that one to negative 11c. Okay? So this is what we will have now. So all we have to do now is to pick up the like terms. And with 15, I think you're noticing that we have 15a here, and then we have minus 12a. So 15 minus 12, that must be easy for you to do. That would be 3a. I'm done with things with a. So let's quickly figure out if we can get another thing. So we have things with b here, which is minus 24b. And what else has got b? This one right here. Okay, so all we have to do is to actually add 24 and 18 over here. And of course, you will get your 42 as your number of b's that are there. So that will be 42b. Okay, it's 8 plus 4, you carry 2, then you carry 1, and then it will be 3 plus 1, which will be a 4, okay? So I'm sure you can do addition. I'm sure that one you can do. Okay, so to finish it off, I'm going to, of course, talk about this 13c, negative 13c. You take it together with its sign, and negative 11c. Now, because they have the same sign, you take the sign, which is negative, and you add the 2. So you have to say 13 plus 11 in this situation. So the negative is already there, and you put your 24 like that. So you just don't forget to put your c, okay? So that's how you do it. If the signs are different, you take the sign of the bigger number and you subtract. If the signs are the same, you take that sign and you add the 2 terms, or 3 terms, whatever number of terms you have. So this is how far we could go with this expression. We don't have any other thing to take. There are no other like terms that we have to take together. So it ends right there. Okay, that was number 2.21. So what did you do with this fraction here? Well, I believe you went and you did something of this sort. So let's go and do number 2.2.2 on the space that is here. So I'm sure you went and this one, we do it here. You split the fraction, didn't you? And then you did minus 15x, and then it's over 3x like this. So once this is sorted like this, now you can actually cancel whatever is common. So what is 3 into 6? It will go 2 times. And remember, this is x to the power 1. So 3 minus 1, because when you are dividing the same base, like you have the same base, you simply subtract the exponents. So the 2 is here. So now for x, you say 3 minus 1, you get 2. Again, how many times does 3 go into 15? It goes 5 times. But the x and the x will cancel. So I'll just be left with minus 5 like that. That would be my answer right there. Okay, so that was that question. So to finish it off, let's quickly figure out what you did on this one. This was again a challenge to distribute, so I hope you distributed properly. 2 things there, so it's 3, x squared times x to the power 1. Remember, you add the powers, so it will be x to the power of 3 now. Okay, and then 3 times 2, you get a 6, and then don't forget the x squared. I'm done with the first bracket. What about the second one? I have to distribute plus 2x. So make sure 2x is distributed on both terms. So 2x times x squared, that would be 2 first for numbers, and x times x squared will be x to the power of 3. It's like x to the power 1 multiplied by x squared. You know, you just say 1 plus 2, you will get x to the power of 3, isn't it? So that we know how to do. Right? So once that one is sorted, we are going to go now and say this 2 times that 3, well, we get 6. And then x times x, we get x squared. Now, time to take the like terms together. And I am seeing some like terms here. This term right here, the first term, together with this term, they are like terms. So they both have x cubed, so they are like terms. So I'm going to say 2 plus 3, which is going to be 5. So my answer will be 5x cubed. And as you are noticing, this 6x squared rather, 6x squared together with that 6x squared, we just add them. They are like terms as well. And that will be 12x squared. That will be the solution for this one. Okay, so that is what I wanted you to do on this simplification. Okay, now we're just going to take care of a few equations, just to remind you of the equations you know already. So how does this work? Okay, when you do equations, you're solving for x now. It's no longer an algebraic expression. This is now an algebraic equation. How do we handle algebraic equations? Well, first things first, remember when you move things from one side of a sign, of the equal sign to the other, we say crossing the bridge. If it's a plus, it will change to a minus. If it's a minus, it will change to a plus. Okay, if it was a division sign, it will change into a multiplication sign. If it was a multiplication sign, well, it will change into a division sign. So the thing is already happening here. I'm going to take 10 to the other side. It was negative 10 this side, but when I take it to this side, it will be plus 10. So it means you leave x on its own on the other side. 2 plus 10 will give us 12. So that right there is your answer for 6.1.1. This one was one of the examination questions that was asked in one of the good years. Okay, what else is here? Again, you need to leave x on its own, solve until x is on its own on the other side. So what will you do first? Well, I'm going to take that 1 to the other side. So 2 or 3 is here. When I take that 1 to the other side, remember it was a plus 1. So when it goes to the other side, it will be minus 1. So in my head, I was not going to do that step, but here it is. It is 2 or 2 when I subtract, isn't it? So what we really do on this step is we will actually make sure we are left with x. So the one thing we have to do is to divide by 2. You may or may not show that step. It's fine if you don't show it. So here, if you do that, you'll be left with x alone, but 2 goes into 2 or 2. 2 goes once there, then 0, then 1. So that right there will be your x value in this situation. These are the seemingly easy equations for starters. Okay, what about here? Now, these were exponential equations, but you were supposed to handle them as well. Now, the way you do these ones is you try to make either the same base on both sides, or you can try to make the same exponent. So in this situation, because x is the base, you cannot change 64 into x to the power something. So you have to try and change to the same exponent, which means find something that is to the power of 3 that will give you 64. And what will that be? Well, that will be 4 raised to the power of 3. Now, because the exponents are the same, it's 3 and 3, it means the bases must be the same as well. So it works just like this. Okay, I hope you are actually grasping what I'm saying. So let me just say, for example, if you had maybe 2 to the power of x is equal to 32, well, rather 32, I'm saying if you were solving, it's a different one to this one. Here we made the exponents the same, so the bases were the same. Here I can make the bases the same, like this. 32 can be written as 2 to the power of 5. So I can easily now, because the bases are the same, now I equate the exponents. Okay, so here the exponents were the same, and here on this one I equated the bases. So it works like that with exponential equations, so just watch out whatever it is that you have. Okay, right. Let's do this exercise now that you know your equations, just for me to check if you really understood your equations. Just solve this one for me. Pause and answer this one on your own. I believe you're done. So here on 4.3.1, I'm just going to rewrite that one, but instead of rewriting it, I'm just going to make sure that I take this 3x to that side. When I take it, remember it was plus 3x, it will be negative 3x when I take it to this side, and then that will be equal to 40. I moved it to that side. So 5x minus 3x, well, this will be just 2x left, and it will be equal to 40. What is the next thing you do to get to your x? Well, you divide by 2 both sides. So the 2's will cancel, and then 40 divided by 2 will be 20 as your solution for that one. So I hope you got that one right. Well, 4.3.2, you had 8 to the power of x. I'm sure you tried to change 32 to 8 to the power of something. I'm sure you tried that, and I'm sure it didn't work. So there are things we call prime numbers, and if it doesn't work with any other numbers, change everything to prime numbers. It's very easy to get to your prime numbers. Like, for example, with 32, I can just say 2 goes into 32 like 16 times. 2 goes into 16 8 times. 2 again, it will go 4 times. And again, another 2, it will go 2 times, and now 2 is 1. Remember, you did stuff like this in your first term. So what it means is that 32 really can be written as 2 raised to the, is 2 times 2 times 2 times 2 times 2, which is the same as saying 2 to the power of 5, isn't it? So the same applies with 8. So if I have 8 over there, I can write it in its prime numbers by starting with 2. Is like 2 in there into 8. You get 4. If 2 wasn't going into 8, I was going to try 3 and then also try 5 and try 7, as long as I'm dealing with a prime number. So 2 there will go again 2 times, then 2 goes 1. So 8 now can be written as 2 times 2 times 2, which is 2 to the power of 3. So what am I saying here? You were supposed to notice that this one, this 8, you could write it as 2 to the power of 3, and then you can put the x there, it multiplies. And then you also write this 32 as 2 to the power of 5. So it's also another way of doing things. So because the bases are the same, now I can really say 3x is equal to 5, and therefore your x is 5 over 3 when you divide both sides by 3. Okay? So that's your solution for that one. So let's finish off this one as well. To distribute the bracket, I believe you understand that by now. So 2 times minus 3, don't forget your signs. Your signs are very, very important. Okay? Then you're going to take 6 to the other side. 14 plus 6. So let me just write that step. Okay? And then your 2x is going to be equal to 20. Therefore, your x, when you divide both sides by 2 like this, so that the 2's will cancel, divide this one by 2, you would definitely get an answer of 10 in this situation. Okay, I hope you actually got that one right. Okay, so we're not going to wind up this lesson until we answer quite a number of equations, because there you need to have your skills ready. So here are some more practice questions. You can go through them, and then I'll quickly go through the answers with you quickly. So let's do 3.1.1 here. So what I'm going to do is to leave this the 7 this side, but I'm going to take 3x to this side. Okay, so, and I'm going to take the 3 to the other side, like that. So 3 changed to plus 3, and then I'm going to say 2x. When minus 3 goes to the other side, it will be plus 3x. So now I'm moving a bit fast. I'm thinking you now understand this. Okay, so dividing both sides by 5, you will get x of 2. So that's the solution for 3.1.1. For 3.1.2, you were supposed to do plus minus the same thing. However, in this situation, you have to let the 4 to distribute it properly. So it will be minus 8x minus 4 times 2. And then minus 4 times minus 1, you get plus 1. Plus 4, excuse me. Negative 4 times negative 1, you will get positive 4. And then there is an equal sign there. Negative 2 should also be distributed into that bracket. So you certainly get negative 6 when you do so for the first one. And then positive 2x. Minus 2 minus 1. That will be positive 2. And then the x is there. Now, make sure to take like terms together whenever, since it's an equation, you take the things with x to one side and the things with numbers to one side. So I'm just going to put that step. You see the 4, it's here. So this negative 6, I'm going to move it to this side. It will be positive 6. Okay? The 2x was already this side. I'm going to shift this negative 8x. When I put it to the other side, it will be positive 8x like this. Now, I believe it doesn't matter where the x values are. Normally, you may want to put them on the left-hand side, but really, it does exactly the same thing. So what is 10 plus 4 plus 6? Well, 10 plus 4 is 14. 14 plus 6 will be 20. And then 2x plus 8x, that will be 10x. If you divide both sides by 2, like I have indicated before, you divide both sides by 10. I'm already getting the answer of 2 here in my head. Okay, so we divide both sides by 10. As you are noticing, the 10 will cancel. You'll be left with just x that side. And 20 divided by 10, it will be 2 times. So 10 will go into 22 times. So that will be our solution for x. Okay, so 3.13. Okay, your last practice question is already showing. So if you are excited about that, you can move forward. So what do you do with this one? Well, this one is a fraction. Please, first of all, just multiply. You're going to multiply both sides by 2. It's like multiply by 2, multiply by 2. So that 2 and that 2 will cancel. You can do a process which we are going to later call cross-multiplying. But for now, this should suffice. Okay, so this expression will be correct like this. I multiplied by 2 both sides. What is the next thing I do? I'm going to take 1 to the other side. It will be plus 1 when I do so. And then your 3x definitely is equal to 9, which when you divide both sides by 3, you will get x of 3. So to get x, you have to divide both sides by 3 on this step here, on the second last step. Okay, I believe you got that one right. So this is your last question here. Try it and please get it right on the equations, and let's move forward to something else afterwards. Okay, so I'm sure you tried your 4.1.1, so I would like to see what you have there. I hope you have a correct answer. So the first thing you did, I'm sure, was to take 6 to the other side like this. Okay, since 6, when it goes to the other side, it becomes plus 6. So that's what I did here. So 9 plus 6 will become 15. So I'm going to put an equal sign there. Now, to get to my x, as you are noticing, this is 3x, which is equal to 15. What about x itself? Well, you have to divide by 3 both sides. So x will be 15 divided by 3, which will be 5. Let's do some distributing here. What is 2 times x? Well, that will be 2x. What is 2 times 4? Well, that will be 8. Then there is that plus 2, and let me just copy everything as it is. Now I'm going to take things with x to one side. You see, at this point, because I am noticing that it's 5x this side and 2x that side, I find it's easier for me if I take 2x to this side rather, to make it minus 2x. You can take things to the other side as well. It's not wrong. So 8 plus 2, let me write it as 10 for now. and then that plus 1, when it goes to the other side, it will become -1. Are we still together on that? So 10 minus 1 will be 9. And then 5x minus 2x would definitely be 3x. So at this point, if you want to get your x value, you just have to divide by 3 both sides. So what do we do then? The 3 will cancel, and then 3 into 9, it would definitely go 3 times. So therefore, your x value will be equal to 3 in this situation. So I'd like to thank you for watching this, and I hope I taught you something here. Okay, thank you.